Welcome to MH2801 video segment on Riemann surfaces and multi-valued functions. So earlier in the previous video segment, we talked about examples of multi-valued functions such as ln z and square root z. Now, how would we deal with such functions? One way, there are actually two ways to deal with such functions. First is to imagine that these functions are actually single valued functions on surfaces that are very complex. These surfaces are called Riemann surfaces. Or the second way to deal with multi-valued functions is to introduce branch cuts. In this video segment, we will talk specifically about Riemann surfaces. Now, the basic idea behind Riemann surfaces is this. Suppose f of z is a single valued function. Then what happens is that if we try to sketch the function, it will look something like this. So if we sketch, say, the real part or the imaginary part, it will look something like this. So here I'm drawing the contour lines of the function f of z. Okay, so this is how a function that is single value would look like. What about a multi-valued function on the complex plane? Then what happens is that, let's say on this particular point on the complex plane, okay, there will be two values for f of z. Let's say one of them is here and the other one is here. And of course, if we move around just a little, this function value is going to change smoothly here, 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 and here. Now also on near the other function value, it should also change smoothly. Okay, so what we should imagine then is that there is one surface that is on which the lower function value is associated with, and then there is also a upper surface, okay, on which the upper value of f of z is associated with. Now I draw the two surfaces as two separate pieces. Now what happens is that in actual fact, these surfaces are connected in some very complex way, maybe something like this. Okay, so that it goes around over here and then turns around and becomes the upper surface, and this can become arbitrarily complicated. Now to show you how Riemann surfaces of standard function looks like, let me go introduce a tool called the Wolfram calculator. So let me first launch Wolfram calculator. On a Mac it's called WolfCalc. Okay, and after it is launched, okay, it wants me to rate it now, so I wouldn't do that now. After it is launched, okay, there is a dialog box that allows you to interact with Wolfram Alpha, and what you would do is you would type in here Riemann surface, okay, and then in the previous video segment we talked about ln z. So let's say we try to plot the Riemann surface of ln z, hit enter, and then your local Wolfram Alpha client will communicate with the server in Wolfram and then return these Riemann surfaces. Now they look kind of small, so let me make them larger. Okay, now they're becoming larger, but they are not that much larger. And also you can kind of copy them, but you can't spin them around to look at the Riemann surface from different perspectives. Now let me also plot the Riemann surface of square root z before moving on to look at other images of the Riemann surfaces. So this is again too small, so let me make it larger. And here it is. So this is the Riemann surface of square root z. Because this is a function of a complex function, you can have the real part of f of z and also the imaginary part of f of z. So you can see that there are two different parts. They look kind of like each other, although it is not absolutely necessary. Frequently, the real part of the Riemann surface and the imaginary part of the Riemann surface looks different from each other. Okay, so these images are kind of small, so let me go to Google and look at other Riemann surfaces. So if you type in Riemann surface in Google, you'll find lots and lots of hits. If you just want to learn how to visualize, so the best thing to do would be just look at the images. Okay, if I click on this, okay, and then I say look at the full-size image. Okay, it doesn't go any bigger. So let's go back. This is actually the Riemann surface of square root z. Okay, let's see what else we can find. So let's go images. Okay, and type in Riemann surface. And see what we can find. And we can find a lot of different functions. For example, we can find this particular Riemann surface down here. Okay, and this Riemann surface is actually the Riemann surface of ln z. Now what it looks like is that it looks like an infinite spiral that goes up and up and up. Now the box of course shows you a small region of the complex plane. The Riemann surface itself actually extends to infinity, both along the real axis and along the imaginary axis. So every of these levels extends to complex infinities. So there are also infinitely many of these different levels, and they are connected smoothly to each other. And you can see here that there is one special point. Okay, this line where there's the Riemann surface has infinite slope. And this particular line here, if you draw it on the two-dimensional complex plane, it's just one point. Actually, it lies along the point z equals to 0. Such points are called branch points. And when we will talk more about branch points when we come on to the classification of singularities, when we reach the Laurent series of functions of complex variables. Okay, so this is the Riemann surface of the ln z. There is another copy of that looks very similar to this, which is the imaginary part of ln z. And what else can we find on the net? So if you look around, there are different kinds. So this is square root. The square root of this is the Riemann surface of square root. And there are of course many very exotic looking Riemann surfaces. For example, this one here. This is an exotic looking Riemann surface, and you can see that there are, okay, the color tells you there are kind of like 4 different pieces to the Riemann surface, and these different surfaces are called branches of the Riemann surface. So this function here has a total of 4 branches, and it is actually the Riemann surface of x to the 1/4. Now let's see if I am right. So if I just close this and then look at yes, so indeed I guess correctly, this is the Riemann surface for z to the 1/4 power. Okay, so that's Riemann surface, and what happens is that on a Riemann surface there is no problem with multi-valued functions. The function f of z that used to be multi-valued is now single value, except that it is single value on a very complex looking surface, and for the purpose of doing analysis and integration, it is actually not convenient. So we actually have to learn how to do branch cuts in order to deal with multi-valued functions. So, but this is one good way to visualize Riemann surfaces and multi-valued functions on it.